I'm Anil Kumar, and in this video we will learn how the trigonometric ratios are related with Pythagorean identity and its application. The question here is, write the following as a single trigonometric ratio and state restrictions if any. So it has got two parts. One is we have to write it as a single trigonometric ratio. The second one is we need to state restrictions if any. The expression given to us is square root of 1 plus tan square x divided by square root of 1 minus sine square x. Now before we begin, let me derive the Pythagorean identities and we'll begin from there. So let us take this as our very basic model from where we can move forward. So let us say that is the right triangle where the angle given to us is theta, for example, and right triangle we have one side as y, the other as x, and this one is r. Since it is a right triangle, we know x square plus y square equals to r square, and if I divide by r square, what do I get? If I divide by r square, I get x over r. X over r is cosine, right? So we get x over r whole square, r whole square, plus y over r whole square equals to 1. X over r is cos, so it is cos square x plus sine square x equals to 1. So this is one Pythagorean identity which we are going to use in this particular expression. We have 1 minus sine square x, right? So if I take this on the right side, what do I get? I get cos square x equals to 1 minus sine square x. You get the idea, right? So I can write this denominator part here as square root of cos square x. Correct? So that is one part. Now let's look into the other identity. We are trying to relate tan now. Tan is y over x. We'll begin with the same strategies. We have x square plus y square equals to r square. We'll divide by x square this time. So if I divide by x square all these terms, then we get 1 plus y over x. Y over x is tan, right? Tan square x is equals to r over x. R over x is reciprocal of cosine, so secant square x. Do you see that? So 1 plus tan square x is secant square x. So we could write the numerator as square root of secant square x. Well, I have purposely done this Pythagorean identity on the side because some students may not remember it. So it's kind of a review for them. So now we have secant square x square root is just secant x, right? So we have secant x. In the denominator, we have cos x, correct? So we have secant x over cos x. Now as you know, secant is 1 over cos. So we get 1 over cos x times 1 over cos x, or we could write this as 1 over cos square x. Correct? 1 over cos square x could also be written as secant square x. You get the idea. So this could be written as single trigonometric ratio, which is secant square x. So that is the first part which we have done, right? The second part is state restrictions. So the restrictions is that the denominator cannot be 0, right? So that means cos x cannot be 0. Now when is cos x 0? So cos x is 0. Let's look into the graph of cosine x. So the graph of cosine x is kind of like this. And we know cos x is 0 at odd multiples of pi by 2, right? So this is pi by 2. This is 3 pi by 2. So odd multiples of pi by 2, it is 0. So we say x is not equal to odd multiples you can get by an expression 2n plus 1, pi by 2, where n belongs to integers, right? So that is how you could write down the restriction on this function, right? So those of you who are doing in degrees, well, this is pi by 2. They can write this as 90 degrees and 270 degrees, correct? And then use the same expression. That becomes 90 degrees, right? So they could use degrees also. This is in radians. So I hope you understand how to solve such questions. So basically, we are using the Pythagorean identities and then writing them as single trigonometric ratio. Thank you.